Hello and welcome to Mr. Alvarez's virtual chemistry classroom. Today we'll be talking about Table G. Our aim for today is how can we determine the solubility of a specific solid and gas in water. On the x-axis, you see that there is temperature. It ranges from 0 to 100 degrees Celsius. On the y-axis, we have solubility in grams of solute per 100 grams of water. So if you had a beaker filled with 100 grams of water, which is 100 milliliters of water, because the density of water is 1 gram per milliliter, you would have the solubility of these 10 substances. On the y-axis, it goes from 0 grams to 150 grams of solute per 100 grams of water. The first definition is saturated. Saturated means that the solution contains the maximum amount of solute per 100 grams of water at a given temperature. If you have a saturated solution, that'll be a point on one of these 10 curves. We also say that a solution that is saturated is at equilibrium. That means that the rate of dissolving is equal to the rate of precipitation. So the rate that the solute goes into solution is equal to the rate that the solute precipitates out as a solid or a gas of solution. Unsaturated means that the solution contains less than the maximum amount of solute that it could hold. That would be under the lines. That would be a point under any of the 10 curves. And finally, we have supersaturated, which means that a solution is containing more solute than it could theoretically hold at any given temperature. That point would be above any one of the lines. There are 10 curves on Table G. 7 of those substances are solids. We know that because most of the time when solids are dissolved in water, as temperature increases, the amount of solute that dissolves will increase as well. That is a direct relationship. The 7 substances that are solids out of the 10 curves on Table G are Ki, potassium iodide, NaNO3, sodium nitrate, KNO3, potassium nitrate, NH4Cl, ammonium chloride, KCl, potassium chloride, NaCl, sodium chloride, and KClO3, potassium chlorate. There are 3 substances that are gases. We can tell that because the solubility of a gas generally decreases as temperature increases. Think about a carbonated beverage. Think about a soda, right? If you want your soda to be bubbly, carbonated, you're going to cool it down first. The worst thing you can do is leave it out, room temperature, open it up. You hear that psst sound and you lose most of the gas. The gas does not want to be trapped inside of your liquid. They want to be moving freely. Those 3 substances that decrease, those 3 gases are SO2, NH3, and HCl. Let's try a couple of practice problems. On the solubility curves worksheet, the directions state for questions 1 through 4, an amount of solute is given and a temperature is stated. If all the solute could be dissolved in 100 grams of water at the given temperature, would the resulting solution be unsaturated, saturated, or supersaturated? Let's look at problem number 1. 60 grams of KCl at 7 degrees Celsius. The first thing we should do is go to 7 degrees Celsius and find KCl right here. So theoretically, if we had 100 grams of water, it could hold about 48, 49 grams of KCl at 7 degrees Celsius. However, we have 60 grams, which would be right about here. Since this point is above the curve, we would say that it is supersaturated. Let's try problem number 2. Problem number 2 states we have 10 grams of KClO3 at 60 degrees Celsius. So we'll go to 6 degrees Celsius and KClO3 right about here. So theoretically, if we had 100 grams of water, it could hold about 28, 29 grams of KClO3. However, we have 10 grams of KClO3, which would be right here. Since the point is under the curve, we would say that is unsaturated. Let's try one more. Problem number 3 states that we have 80 grams of NaNO3 at 10 degrees Celsius. We find 10 degrees Celsius. We go to NaNO3, which is right about here, and I see that at 10 degrees Celsius, 100 grams of water can hold 80 grams of NaNO3, which is what we have. The point is on the line. If the point is on the curve, we say that that is saturated. On the Regents, you can also be asked to read Table G. The directions state, determine how many grams of each substance will dissolve in 100 grams of water at a given temperature. That's the conditions we have. We have 100 grams of water. So we're just reading Table G. So if we have Ki at 10 degrees Celsius, how much Ki can 100 grams of water hold? So we go to 10 degrees Celsius, and we find Ki, which is all the way here at the top. And the point is somewhere between 130 and 140, a little bit above halfway. So I would say 136 grams. Now, a graph question on the Regents will give you a little bit of leeway, plus or minus 2. So if you said 135, that would be acceptable. If you said 134, probably acceptable. And if you said 137, that would also be acceptable. So you have a plus or minus 2 off of the Regents stated correct answer. For problem number 7, SO2 at 40 degrees Celsius. You go to 40 degrees Celsius, you find SO2. Once again, that's right in the middle of 0 and 10. I would say 5 grams of SO2. And once again, if you said 6, you said 4, you're still in good shape with the Regents, if this was a part 2 of your response. Last one, KNO3 at 50 degrees Celsius. Once again, 50 degrees Celsius, we find KNO3, which is a little bit farther up, right about here. And again, halfway in between 80 and 90. I'm going to say it's a little bit less than halfway, so I'm going to say 84 grams. Or if you said 85, 83, that would also be acceptable. For these next set of problems, the directions state, determine how many grams of each substance will dissolve in 200 grams of water at a given temperature. Remember, Table G is based off of 100 grams of water. So for each of these problems, since we're doubling the amount of water, we'll have to double the amount of substance dissolved at that temperature. For example, SO2 at 5 degrees Celsius. Let's continue as we normally would. Let's go to 5 degrees Celsius and find SO2. Right about here. Now, if this was a regular problem, 100 grams of water, we would say that is about 19 grams. However, since we have 200 grams of water, we must double this. 19 grams times 2. At 5 degrees Celsius, 200 grams of water can dissolve 38 grams of SO2. Let's try one more. NH4Cl at 75 degrees Celsius. So let's go to 75 degrees Celsius, go to NH4Cl, which is right here. Let's say halfway in between 60 and 70, so let's say 65 grams. But once again, we have 200 grams of water. So once again, we must double that number. 65 times 2 would be 130 grams. In 200 grams of water at 75 degrees Celsius, that water can hold 130 grams of NH4Cl. Finally, we could also halve the amount of water that we have. The directions state determine how many grams of each substance will dissolve in 50 grams of water at a given temperature. Once again, table G is based off of 100 grams of water. So since we cut the amount of water in half, we will have to halve the amount of grams each substance can dissolve at a given temperature. For example, NH3 at 90 degrees Celsius. We carry on as normal. We go to 90 degrees Celsius and we go to NH3. Seems like we have a nice easy number of 10 grams. That, once again, is for 100 grams of water. Since we have 50 grams of water, we cut the amount of water in half. We also have to cut the amount of solute, the amount of NH3 in half. So 10 divided by 2 is going to be 5 grams of NH3. For the last one, number 17, Ki at 15 degrees Celsius. So we'll go to 15 degrees Celsius, find Ki, all the way up here. Looks to be another nice, easy number. So normally, if I had 100 grams of water, that could hold, at 15 degrees Celsius, it could hold 140 grams of Ki. Once again, I have 50 grams of water, so I must cut this number in half. 140 divided by 2 is 70 grams of Ki. Thank you for joining Mr. Alvarez's virtual chemistry classroom. Today we learned about table G, saturated solutions, unsaturated solutions, and supersaturated solutions. We also learned how to read table G if you had 100 grams of water, if you doubled that to 200 grams of water, or if you have the original amount to 50 grams of water. I hope you learned something today. Thanks for joining us, and have a wonderful day. See you again soon.